Dear students, now we are going to see example sums in mensuration. That is from example 7.26. Okay, we are start from there. First one, example 7.26. Arul has to make arrangements for the accommodation of 150 persons for his family function. For this purpose, he plans to build a tent which is in the shape of cylinder surrounded by a cone. Each person occupies 4 square meter of the space on ground and 40 cubic meter of air to breathe. What should be the height of the conical part of the tent if the height of cylindrical part is 8 meter? Okay, see here, Arul has to make arrangements for accommodation of 150 person for his family person. Okay, that one person Arul, he makes arrangement for the family function. How many persons are here? 150 persons. So there are totally 150 persons. Okay, he plans to build a tent which is in the shape of cylinder surrounded by a cone. Okay, he made a tent. The tent is, see, cylinder surrounded by cone. Okay, the tent is combined shape of two figures, combined. That is, one is cylinder and another one is cone. Okay, see the diagram. See, this is the cylinder, cylindrical part, and see, this is conical part. So he is made the tent like this shape. See, if I hide here means, see, you are now visible the cylindrical portion. Now see, I am hiding this. Now this is the conical portion. So he made tent like this, combined shape of two figures, that is cylinder and cone. Then what is given here? Each person occupies 4 square meter space on the ground. In ground area, each person needs 4 square meter and 40 cubic meter of air to breathe. Okay. What should be the height of a conical part of the tent if the height of the cylindrical part is 8 meter? So what we have to find here, what should be the height of the conical part. So here we have to find height of the cone. Okay, then what is given? Height of the cylinder. Height of the cylinder 8 meter. That is given here. So we have to find height of the cone. Okay, now it's clear. See the diagram. This is combined shape of cylinder and cone. Let us take H1. H1 be the height of the cylinder. Okay, H1 is the height of the cylinder, and H2 is the height of the cone. Okay, now area for one person, area needed for one person, that is given in our question is 4 square meter. So that is equal to 4 square meter. Total number of persons, see the question, how many persons are here? 150 persons. So the total number of persons equal to 150. Therefore, the total base area equal to 150 into 4. Because the total number of persons is 150, then area needed for one person is 4. So, I write here 150 into 4. Now, multiply these two. 150 into 4 is 600. Okay, see here, total base area is given. So many sums already I said no. Base area, base is in the shape of circle. So what is the area of circle formula? Pi r squared. So pi r squared equal to 600. Now substitute the corresponding values. Value of pi is 22 by 7 into r squared, that is equal to 600. Okay, now here we have to find r squared. So keep the r squared here, change the remaining terms to the another side. Here already 600 is there. Then while changing the side, 22 by 7 becomes 7 by 22. Now simplification, 2 table, 11 times, this is 300 times, multiply, 7 into 3, 21. So 2100 by 11. No need to taking square root, keep this one as it is, value of r squared. Because you substitute the formula, so keep the value of r squared equal to 2100 by 11. Mark this as 1. Okay. Next, volume of the air required for one person. See the question here, they given the volume of air needed for one person, that is equal to 40 cubic meter, that is 40 meter cube. Now we find total volume. How many persons here? 150 persons. So the volume of air required for 150 persons equal to 150 into 40. Multiply these two. You get 6000 meter cube. Okay. See, volume of cylinder plus volume of cone. The total area, volume of required for 150 persons, no, that is the total. See this figure here. One cylindrical part, one conical. So volume means the both cylinder and cone. Okay. So see here, take volume of cylinder plus volume of cone equal to 6000. That this answer. Okay. Now write the formulas. Volume of cylinder formula, pi r squared h1. Why here h1? Because h1 is the height of the cylinder. Then volume of cone formula, 1 by 3 pi r squared h2. Why here h2? h2 is the height of the cone. So we take this one as h2 equal to 6000. Now in both terms pi and r squared is common. So I am taking pi and r squared outside. So the remaining are h1 plus 1 by 3 h2. That is equal to 6000. Substitute the values. Value of pi is 22 by 7. R1. See, already here we found no that r squared equal to 2100 by 1. Sorry, 11. Substitute the value here. 2100 by 11 into h1. Value of h1 is 8 plus 1 by 3 h2 equal to 6000. Okay. Now keep the numbers in bracket. No, 8 plus 1 by 3 h. Keep this one here. Side change the remaining numbers. Remaining these numbers bring into this side. Okay. 8 plus 1 by 3 h2 equal to, already 6000 is here. While changing side, the number gets reciprocal. So the number 7 and 11 which are in denominator, this one comes into the numerator. So into 7 into 11. Then the number 22 into 2100 is in numerator. This one comes into the denominator. Okay. Now simplify this one. 2020 get cancelled. 2 table. This is 30 times. Again 2 table. 3 table 10 times. This is 11 table. So the final answer is 10. Okay. 8 plus 1 by 3 h2 equal to 10. Now bring this 8 to this side. So remaining term 1 by 3 h2 equal to 10. While bringing this 8, here addition. So it becomes minus 8. 10 minus 8 equal to 2. So now h2 equal to 2. See here 3 is in denominator. While changing side it comes into the numerator. So 2 into 3 equal to 6 meter. Therefore the height of the conical tent h2 equal to 6 meter. Next one, example 7.27. A funnel consists of frustum of a cone attached to a cylindrical portion 12 cm long attached at the bottom. If the total height be 20 cm, diameter of the cylindrical portion be 12 cm and the diameter of the top of the funnel be 24 cm. Find the outer surface area of the funnel. See here, one funnel consists of a frustum of a cone attached to a cylindrical portion. See, already I said no, you know frustum. It is in the half part of the cone. Okay. So, see in this figure, this is frustum shape. This is like table lamp shape. Okay. Frustum. This is attached to cylinder. See, this is cylindrical part. Is it clear? See, this is cylindrical part. That frustum shape, this is attached to this cylindrical part. This is conical frustum shape. Okay. See. Now the two figures are combined. One figure is this cylinder. Another one is this frustum. Now see, this is looks like a funnel. Okay. Then 12 meter long. The cylindrical portion 12 meter long. So height of the cylindrical part is 12 centimeter. Then if the total height be 20, this total height is 20. Diameter of the cylindrical portion. This is the cylindrical portion. This diameter, this is 12 centimeter. And diameter of the top of the funnel, see, this is top of the funnel, this is the diameter. This is 24 centimeter. Find the outer surface area of the funnel. Here we have to find outer surface area. Okay. Now see, here inner and outer given, no, so you have to take the radius as capital R and small r. Let capital R be the top radius and small r be the bottom radius of this frustum. This is top radius 12 and this is bottom radius. Next, H1 be the height of the frustum, this height H1, and H2 height of the cylinder. This is H2 height of the cylinder, this H1. This is height of the frustum. Okay. Given that, see in question they given that radius top diameter is 24. So while finding radius you divide this one by 2. 24 by 2 is 12. And another one, this is 12. Bottom diameter is 12. So 12 divided by 2 is 6. And height of the cylindrical part H2 equal to 12. This one. Height of the cylindrical part H2 equal to 12. Now we find H1. So the total height is 20 minus the height of H2. 12. So 20 minus 12 equal to 8. So 8 centimeter is the height of the frustum. Okay. Now you find slant height L. L equal to square root of, here 2 radii are there. So I take capital R minus small r the whole squared plus H1 squared. Substitute the values. Capital R is 12, small r is 6. So 12 minus 6 the whole squared and H1 is 8 squared. 12 minus 6 is 6 squared plus 8 squared, that is 6 squared is 36, 8 squared is 64. So 36 plus 64 is 100. Square root of 100. Taking square root, you get L equal to 10 centimeter. So slant height L equal to 10 centimeter. Next, here in question I asked us to find outer surface area. So write the formula. Outer surface area equal to 2 pi RH plus pi into capital R plus small r into L square units. See, pi is common in both terms. So I take pi outside, write the remaining 2 RH2 plus capital R plus small r into L. Okay. Now substitute the values. Values of pi also you substitute here itself, 22 by 7. Then 2 into r is 6, H2 is 12. Plus here capital R is 12, small r is 6. So 12 plus 6 is 18 into L is 10. Okay. Now multiply all these. 2 into 6, 12. 12 12s are 144. 18 into 10 is 180. Then value of pi is 22 by 7. Add these two. You get 324. Then multiply and divide by 7. Finally you get 1018.28. So therefore, outer surface area of the funnel is 1018.28 centimeter cube. The next example. Example 7.28. A hemispherical section is cut out from one face of a cubical block. See, one hemispherical section. See, this is hemispherical. This section is cutting out from one face of the cubical box. You know cube. You all know that no cubical block. Okay, one side from that cubical block, one side we are cutting out that hemispherical section. Okay, see the figure. Such that the diameter L of a hemisphere is equal to side length of the cube. Here given diameter L, okay, diameter L of a hemisphere in this pink color portion, hemisphere. that is equal to length of the cube. This is cube, no, cubical portion, blue color. That length and this diameter both are equal. Okay, determine the surface area of the remaining solid. Here we have to find surface area. Surface area of the remaining solid. We are taken out that pink color portion out. So we have to find surface area of the remaining cubical portion, that blue color remaining portion. Okay. So let R be the radius of the hemisphere R. Okay. Then given that in given question what they given, diameter of the hemisphere is equal to side of the cube. Okay, that both are equal. L, they are given L is the diameter of the hemisphere. L is the diameter of the hemisphere, and also given that the diameter of hemisphere is equal to side of the cone. So diameter of the hemisphere equal to side of the cube equal to L. Okay, then radius of the hemisphere. So diameter is L, then radius, that is L by 2. Radius is nothing but diameter by 2. Diameter is 2 means it's 2 by 2. Diameter 10 means 10 by 2. But here diameter L. So radius is L by 2. Next, we have to find the remaining area. We are taking out one hemisphere outside. So we find the remaining portion in that cubical portion. So TSA of the remaining solid equal to surface area of the conical part plus curved surface area of the hemispherical part minus area of the base of the hemispherical part. Okay. Now see cubical part. In lower classes you are learned area of the cube formula 6a squared. Okay. A cube. That is the formula of cube. 6 into edge. Edge means what? That side of that cube. So 6 into h whole cube. Okay. So 6 into h the whole square, because area, so the square plus hemispherical part, CSA of a hemispherical 2 pi r squared minus area of base. So many sums we saw, no, area of base. Base is in the form of circle, so area means it's pi r squared. Here we are taking out, cutting out, so cut it out. So we are putting minus sign here. Okay. Now simplify this one. 6 into h the whole squared plus, see here, 2 pi r squared, here pi r squared, that is what is mean 1 pi r squared. So 2 minus 1 is 1 pi r squared. Now 6 edge is given what? L, that is diameter. So L squared plus pi, value of r. Value of r what we found here? L by 2. So L by 2 square, the whole square. See here I am writing here 6 L squared plus pi L squared by 4. Okay. Here denominator 1. Taking LCM. 1 into 4, 4. So multiply this 6 also 4. 6 into 4, 24 L squared plus pi L squared divided by 4. Okay, now I am taking, see L is common in both terms. So I am taking this L squared is outside and 1 by this 4. 1 by 4 into L squared equal to into 24. The remaining terms is 24 plus pi. Okay, 1 by 4 L squared common. The remaining terms 24 plus 5. Therefore, total surface area of the remaining solid equal to 1 by 4 24 plus pi into L squared square units. Thank you.